The third pathways that most commonly reports on the pathways of pollution is the subsurface and groundwater pathways. These pathways is basically is a long-term pollution mechanism. Basically, we don't really aware that this process occurred in our environment. Basically, it's a combination of soil and water interaction where, as we know here on the image, we can see that there is some of activities, industrial activities that produce a lot of wastewater, and then maybe a spill on the soil system, and then the soil can, leaching the pollution deep into the soil system. And this process is not really fast or reliable, or like it's really massive things like point source or non-point source pathways that we people just dump or like discharge all of the wastewater. This pathway is a long-term things. I mean, like leaching here from the wastewater or from the pipelines that could infiltrate the pollution to the soil system. It could be the accumulation. We don't really aware or realize that the pollution mechanism coming. So all of the pollution that accumulate in the soil surface here, they can down they could goes to the unsaturated zone, or we could say the Fedos zone, where the air and water um, accumulate on those site. So basically, the unsaturated zone, the leaching or the soil system on the surface of here in the soil system, they meet the water and air system. The unsaturated zone is known as the aerobic zone, where this is play the important role to do some biological things, biological process that conducted in the sorry, in the water system under the ground. So after the unsaturated zone, all of the pollution can goes to the saturated zone or the water system or groundwater system, that the pollution that accumulate from leaching and then goes to unsaturated zone can goes to the saturated zone where the groundwater uh, has on those soil and water layer system. The groundwater that pure has the purity, high purity before, and then when they met the pollution that accumulate in on this unsaturated zone can mix together and try to degrade the quality of the groundwater. The mixture between the pollution and groundwater is known as the seepage. So the seepage basically the groundwater that get contaminated from this uh, pollution from the top of the soil or and the unsaturated zone. The seepage itself goes to the migration of the groundwater. As we know that groundwater system, they have their own paths on the hydrological system that can goes to the aquifer that makes the pollution from the groundwater can get distributed to all over the aquifer pathways or groundwater pathways. So that's also, again, this is the long-term processes and also unidentifiable, meanings that the pollution can be something in Medan, for example, but it can goes to the migration pathways, goes to maybe the other area outside of the Medan. So this is the long term, and then we couldn't identify the source of the pollution that sometimes not really occur in the area of the groundwater system. So again, this is the subsurface and groundwater pathways that commonly also get water get contaminated from the water system. The four pathways or mechanism on the water contamination can be from the biological pathways. As we see here, the pollutants can goes to the water system, or it can be degraded by microbes on the surface or on the water system, and then there is a lot of things occur here in the water system, it could be biodegradation, where the microbes or microbiological or living organism degrade the pollutants. Again, the pollutants that degrade by the microbes, sometimes it could be something good or it can be something worse. For example, if they produce a simple molecule, it can be good for the environment. But if they form the radical compounds as the incomplete of degradation process, it could be worse than the pollutant itself. And again, the pollutants sometimes they do the bioaccumulation where the living organism, for example, fish, can consume those pollutants. For example, the heavy metals. The heavy metals, we found a lot of heavy metals on the fish near the, for example, the landfill area, where the landfill produce heavy metal, and then the heavy metal goes to the water system, let's say the river, and then the fish on the river consume the heavy metal through their metabolism, and then we could see that the heavy metal is already on those fish. And then when the fish get consumed by the other fish or even with the humans, that the biomagnification uh, occur or happens when the small fish consume the heavy metal, and then the big fish consume the small fish, and then the heavy metal containings on the small fish now uh, goes to the big or bigger fish, meaning that the bigger fish now have the heavy metal. So this is the biomagnification. And then we don't know that the big fish can consume a lot of small fish that contain the heavy metal, and then they can get accumulated on those big fish. Biological pathways could be beneficial for the environment if the living organism degrade the pollutants. Again, like we mentioned before, sometimes the like biodegradation process could be a complete process where the living organism or the microorganism can degrade completely the pollution to be something like smaller as safer molecules, but sometimes the living organism they don't really complete the process. Again, because the massive amount of the pollution on the water system that makes the biological things, like the microbes, couldn't complete the process. When the microorganism cannot complete the biodegradation process, it could form a very radical molecules that could be worse than the pollution itself. Biological process could exacerbate risk. That's meaning that for example, the incomplete biodegradation product, and then through the bioaccumulation and biomagnification, they could transform or distribute all over the area. For example, there is a the fish that contains the heavy metal and near the landfill area, and then the fish can go through all the river system, and then we could find the fish on the area where there is no heavy metal reported before. And then when we catch the fish, and then we bring to the labs, and then we could see that okay, this fish contains a lot of heavy metal, and then we declare that the area of the river now has the heavy metal. So those mechanisms make it possible that the fish sometimes bring the heavy metal from different area, not really in the area where we catch the fish. So this is the biological pathways where the contamination could be distributed all over the water system, where they have a lot of living organism that can be transport all of the pollution in the area. Uh, the last for the pathways of on the water contamination is the hydrological and surface pathways. Basically, this is the most massive things on the water contamination, where the way of pollution contaminated water is through the surface runoff that we mentioned before. Is this process also a part of sometimes a part of point or non-point source of non-point source pathways, where the water get contaminated through the hydrological system. As we can see here in the image, like for example, the agricultural activities here, when the rains comes and then all of those pesticide, herbicide that spread through all the plants here get washed by the rainfall, and then all of the agricultural products goes to the water system and then contaminated the water. The hydrological and surface pathway can be also from the sediments near the water source. For example, the sediment, as we know that sometimes they contain a lot of organic carbons that can be from the land. And then when there is a high stream of water, and then the land get eroded, and then also contribute in the water contamination system. Again, here the hydrological and surface pathway is mostly as the most reported pathways on the water contamination, where it could contaminate the water through the direct uh, uh, mechanism where the pollution get washed by the hydrological cycle through the rain, evaporation, and through the um, hydrological things. Okay. The process include the surface transport through the hydrological pathways before entering the water source. Yeah, it's like I mentioned before, because the hydrological things, water can goes from the upstream to downstream, and then during the hydrological pathways, the sometimes the water transport the pollution. The pollutant transport are fast, most reported, and getting worse by climate change. Again, a long times ago, as we know that most of people they plants their their area or plantation during uh, uh, the in the transition before the dry area to the dry season to the wet season. But now, as we see that the climate change is unpredictable, we don't really know when to plant the plantation. Sometimes we do fertilizer in the morning, and then in the afternoon the rainfall comings make the all of the fertilizer get washed on the afternoon. That's also be a disaster, not only on ecological things but also in economic things, where the fertilization on the plantation is not really uh, efficient. Again, the climate change make the water contamination getting worse, where a lot of the pollution can goes to the water river, water source, and then getting worse due to the climate change that makes everything unpredictable. Again, as the conclusion, I try to make a table that conclude all of the pathways on the water contamination, where the point source pathways mostly related to the direct or single identifiable discharge pathways, where the non-point source is the opposite things from the point source, where it's unidentifiable, it's broad, and it can be coming from different source of pollution. And subsurface of groundwater pathways is includes the soil layer, groundwater aquifers that it could be a long-term pollution processes, and there is a biological pathways that includes the living organism during the water contamination process, and the hydrological and surface pathways as the most reported pathways on the water contamination process. And here there's the main drivers and typical contaminants, transport mechanism, and key characteristic from those pathways on the water mechanism. So as we see here, the contamination, the main drivers here, we could see that the point source mostly like direct discharge, or non-point source can be something accumulation from rainfall, land use, or runoff and everything, and subsurface mostly for soil infiltration, leachate, septic tank seepage, and the biological pathways could be some microbial activities, and the hydrological is the combination between the point source, non-point source, through the rainfall, flooding, drainage, and etc. Again, this is the second meeting on the how the water get contamination, and then the next in the third meeting we will talk mostly about the chemical process in the atmospheric environment. Again, thank you so much for your attention, and we'll see you again in the third meeting. Thank you.